all function must satisfy the equation. Okay. R partial R over partial alpha must equal to partial I over partial beta, and partial R over partial beta must equal to minus partial I over partial alpha. Okay. Okay. F of C, yes, F of C is equal to F alpha plus iota beta. Yes. And I have already defined that F derivative. I have already explained in a previous lecture. That will be equal to 0. Okay. This part may be divided into two parts. Yes. Because every function in derivative we must write in the partial derivative. First time that will be one will be equal to 0 and other will be approach to 0. Okay. One minute. Before writing in this way, this will be equal to this. Okay. And this may be right. This is real. This function, as this is parameters. This will be equal to this minus, I think this one maybe cover over. Yes, it's covering. Okay. This equal to this. This real imaginary, this is divided into this. This is divided into this. Okay. And limit approach to 0. We may write alpha approach to 0, beta approach. Sorry, these are delta. Sorry, that's my mistake. Delta. Divided by delta alpha plus iota delta beta. Okay. And this may be right as yes, this may be right as R alpha plus delta alpha minus R alpha okay, this plus iota I, yes, alpha plus delta alpha sorry, may be right as R alpha plus delta alpha and beta plus delta beta. R is function of this, okay, minus R alpha beta minus plus iota I alpha plus delta alpha beta plus delta beta minus I plus minus I alpha beta. Both will be divided by delta alpha plus iota delta beta iota iota delta alpha plus delta alpha plus iota delta beta. Okay, or imaginary. Okay, so yes, we consider two cases. One, delta alpha approach to 0, but delta beta equal to 0. Okay. As partial derivative, one will be treated as a constant and one will be as a. Okay. So FC will be equal to yes. Limit delta alpha approach to 0, delta beta is equal to 0, exactly equal to 0. Okay. So you have R alpha plus delta alpha beta as it, delta beta will be 0, minus R alpha beta divided by beta is 0, delta alpha. Okay. Okay. And plus iota, yes, I alpha plus I, this I is multiplying, okay. Alpha is approach to 0, okay, and beta is okay. I is function of alpha plus delta alpha, beta as it, minus I alpha beta divided by delta alpha. Yes, this is derivative of, because beta is constant, beta is not changing with respect to this derivative, but alpha derivative is with respect to alpha. So this is partial R over partial alpha plus iota partial I over partial alpha. Yes. Now, second condition is delta beta approach to 0, but delta alpha is equal to 0. Okay. In this case, Fc is yes, delta alpha is 0 and delta beta is approach to 0. Okay. Yes. In this case, again, now R alpha beta plus delta beta, beta plus delta beta, minus R beta. Yes. Alpha beta. Alpha will be treated as constant and beta is changing. Okay. Divided by, yes, iota delta beta. Iota delta beta. Yes. Plus iota will be cancelled with the iota. Iota beta will be cancelled with the iota. I will be alpha beta plus delta beta minus I alpha beta divided by iota delta beta. This iota will be cancelled with this iota. Okay. Yes. So FC will be equal to, yes, FC will, derivative of FC will be equal to limit delta alpha approach to 0, delta beta, delta alpha is equal to 0 and delta beta approach to 0. In this case, what is this? This will be 1 over iota partial r over partial beta plus iota partial I over partial beta. Yes, iota. Okay. So if I say that, if I define that, 1 minute please. This is equation X, okay, and if I say this is equation Y, and we know that, yes, as we know that they are making angle 90 with each other, since real and imaginary part are linearly independent, as you may observe from this figure. So then, we may compare their coefficient in X and Y. So if we compare real part with the real, alpha, I have already explained, that was your question. Alpha and beta are real. Beta is not a imaginary number. Alpha and beta both are real number, but when we multiply with the iota, then that will be orthogonal to each other. Okay. So in this case here too, I and R are a real number, but it helps us to distinguish what was the along the imaginary axis, what was the. So if we compare the X and Y, this is the real part. This is real part of this, and this is real part of this. These are the real. This and this are the real. Okay. So what you have, partial R over partial alpha will be equal to partial I over partial beta. C1 satisfies C1. Okay. And this is imaginary. And here this is imaginary, but we may write it as minus iota. Why? Because 1 over iota is equal to minus iota. Okay. So we may that is one step. Okay. 1 over iota is minus iota. So so this and blue line, and so this will be an imaginary part, and so I over, you may say that minus partial r over partial beta is equal to partial I over partial alpha, or you may say that partial r over partial beta is equal to minus partial I over partial alpha. C2, oh sorry, this is C2. This was C1, this is, so that is the proof of the, kya? 1 over aorta multiplied by aorta, okay, because that is equal to -1 and this is equal to -1. Yes, thank you very much.